In this video, I'm going to be dealing with integration of exponential functions. We've been told to integrate 10e power 5x dx. So out of that, to integrate this with respect to x, so what we're going to do here, we're going to say let if example n letter to be equals to 5x. So out of that, if we differentiate this du dx, if you differentiate anything with respect to x, you put there dx, so this would be equals to, I'm going to have only 5. Now let dx the subject, so this is going to be du divided by 5, which would give me the x. So the next thing here is to come back to this, and then we substitute in du divided by 5. So the next thing we're going to say integral of 10e, of which 5x was equals to u dot. So we are going to have in the place of dx having du all over 5. So and so this would be 1, this would be 2. So we are going to have e power u du. So if we integrate this, we are going to have e power u plus an arbitrary constant. So that means that I'm going to have e to power 5x plus c, and therefore this is how we would integrate this. X e to power 2x squared plus 1. Integrate this with respect to x. For example, k be equals to 2x squared plus 1. And therefore, dk dx respect to x would be equals to, I'll have 4x, and this would be a 0. So the next thing here, I want to find dx. So dk all over 4x would be equals to dx in this case. Integral of x e to power k, yes. And then for dx, we are having dk all over 4x. But now this is going with this, and so we are remaining with the integral of e to power k dk all over 4 in this case. Therefore, this would be e to power k all over 4 plus c. And so the next thing here, but we know that k, so this would be e power, we're having 2x squared plus 1 all over 4 plus c. 4x e power x squared plus 1 with this with respect to x. So to integrate this, I'm going to separate this and say I'm going to be integrating 4x e x squared dx plus 1 dx in this case. So out of that, to integrate this, I'm going to say let, this time let's use m, would be equals to, I'd have x squared, and so the m all over the x would be equals to 2x in this case. So let's get dx. So the m all over 2x would be equals to the x. And so to work out this, I'm going to have, this is going to be the integral. I'm going to have 4x e power m, no, so then the x we're going to have here, this is going to be the m all over 2x, and then we are having our plus x. So we are going to have something that's going to be, this is going to be 1, we are going to have 2x1, so we're going to have here, this is going to be integral of 2 e power m the m plus x, and so this is going to be 2 e to power m plus x plus an arbitrary constant, and therefore this is going to be 2e, of which our m is x squared plus x then plus our arbitrary constant x e 2a x squared as my power, if k is equals to 2a x squared, and then the k over the x would be equals to, I'm going to have something here, so I want to differentiate this, and so I'm going to have, this is going to be 4a x in this case, because we are taking this as constant. So this is going to be this, and now let's get dx. So dk all over I'm going to have here, this is 4ax, and then this would be equals to dx. So having worked out that, the next thing here we're going to have here, so this is going to be integral of x e, we assign this to be k. Awesome. Having made that to be k, now the next thing is, now let's substitute for dx. So this would be dk all over 4ax. So here I'm going to have something that this will go with this, and so I'm going to have the integral of e power k, e to power k over 4a, but here I'm having the k. And so if you integrate this, you're going to have e power k all over 4a plus our arbitrary constant, but k was assigned to something. So this is going to be e power 2a x squared all over 4a plus c, in this case squared into 4x cubed plus 5, but the whole of this is to power 5, and we are integrating this with respect to x. So here what we're going to do, if we look on the inside, that if we differentiate on the inside, we can get a component that contains x squared. So let's do it. So if u is equals to 4x cubed plus 5, and the u dx to be equals to, I'm going to have 12x squared. So let's get dx. So du all over 12x squared would be equals to dx in this case. So let's put it in. So that means that we're going to have the integral of x squared into, this is going to be u to power 5, then the x is going to be du all over 12x squared. And so I'm going to cancel this with this. So I'm going to have the integral of u to power 5, so all over 12, this is our 12, then I'm having here du. So I'm going to have, this is going to be u to power 6 all over 6 times 12 plus our arbitrary constant. And so this is going to be u, we have our u as to something. We had 4x cubed, so this is 4x cubed plus 5 to power 6 all over, this is going to be 72 plus our arbitrary constant. And so cos of x all over 1 plus sine squared x. And so to work out this with respect to x, to work out this, what I'm going to do, I'm going to say that let u be equals to sine of x. And so the u dx would be equals to, I would have here, this would be cos of x in this case, but I'm interested in the x, so the x would be equals to the u all over cos of x. Now having got this, now I come back here, so I say integral of cos of x all over, so this is going to be 1 plus of which sine of x, so this would be u squared. So here we're going to multiply this by the u all over, we're going to have cos of x, and so this is going to be going with that, so we are going to have something that's going to be integral of the u all over 1 plus u squared. And so from here, what we're going to be doing is going to be tan substitution. So if I have u be equals to tan theta, and so if I say that du over d theta be equals to sec squared theta in this case. Now, what we are interested here is like we want to get what du would mean, and so what we are going to do here, so du in this case would be equals to sec squared theta d theta. Now, having got that, if you put it back there, we are going to have something that's going to be, we're going to have du, which would be sec squared theta all over. I'm having now, this is going to be 1 plus tan squared theta. Then we are going to have something that's going to be the theta in this case. And therefore, if we work out this, we will find that this is going to be the integral. Remember, if you have, let me use some small space here. So if you have sec squared theta, this would be 1 plus tan squared theta. And therefore, this would give me a 1. The whole of this and this would give me a 1. Therefore, I'm going to have the theta. Yes. So the next thing here, I'm going to have theta plus our arbitrary constant, but of which theta was equals to something. Theta was equals to something. So if we have u is that, so this is tan inverse of u plus c, of which u was something, and then we have our u, of which u was sine of x, and therefore, so I would have tan inverse of sine of x plus c in this case.